examples. So first we are going to see what is Young's modulus, or its other name for the Young modulus is modulus of elasticity. The ratio between tensile stress and compressive stress to the corresponding stress is constant. This ratio is known as Young's modulus or the modulus of elasticity, and it is denoted by E. So you can see here E is equal to tensile stress or compressive stress divided by tensile strain or the compressive strain. Already we have seen what is meant by tensile stress, what is meant by compressive stress in a previous lecture, what is meant by tensile strain and what is meant by compressive strain also we have seen in last lecture. So if you are going to represent the Young's modulus or modulus of elasticity as capital E, we can write like this: E is equal to stress sigma divided by small e, we are going to use for the strain. Okay, so this is simple definition. Young's modulus or modulus of elasticity, the ratio of, okay, stress to the strain. Simple thing. Okay, next, after the Young's modulus or modulus of elasticity, next is modulus of rigidity or shear modulus. What is meant by now modulus of rigidity and shear modulus? The ratio of shear stress to the corresponding shear strain within the elastic limit is known as a modulus of rigidity or the shear modulus. See, important thing is this: elastic limit. The ratio of shear stress to the shear strain within the elastic limit is known as a modulus of rigidity. We have already seen what is meant by elasticity and what is meant by elastic limit also. Okay, so the definition of modulus of rigidity is ratio of shear stress to the shear strain. Okay, so and this modulus of rigidity is denoted by C, or sometimes it is denoted by capital G, or is denoted by the capital N. I can write here that is capital C or capital G or capital N is equal to shear stress divided by shear strain. Okay, and we can represent like this: the shear strain and the shear stress. And next important thing is the factor of safety. What is meant by factor of safety? When you are going to consider the design of concrete structure, okay, or any design steel structure, in that case we have to consider the factor of safety. Okay, safety is our prime thing in the design. Okay, so we have to consider the factor of safety. What is meant by this factor of safety now? Okay, the factor of safety is a ratio of ultimate stress divided by permissible stress. Okay, so this is simple definition of factor of safety, that ultimate stress divided by permissible stress. Ultimate means, if you are going to take the example of my torch steel, in that case if stress in the torch steel, ultimate stress is suppose 500 Newton per mm square, in that case 500 divided by permissible, if suppose that is 400, the ratio you have to take 500 by 400, and that is factor of safety. Okay, for your information, in concrete structure always we are going to use load factor 1.5 for calculating any design or doing any design. Okay, next, after this factor of safety, next is constitutive relationship between stress and strain. Up till now we have seen what is meant by strain, what is meant by stress, we have seen the various technical terms, okay, of the in mechanics of solids. Now we are going to see, if you know the what is meant by stress and strain, the definition of stress already you people know. The force per unit area is called as a stress, and the ratio of change in length to original length is called as a strain. Okay, what is relationship between these two, that we have to see, but that relationship is depend upon which type of dimensions we are going to use. So for one dimensional stress system, where we are going to consider only one dimension, okay, we are going to consider only unidirectional stresses, that is for normal stress in one direction only. In that case, what is relationship between stress and strain? So here the stress and strain relationship is similar, that already we have seen the formula, that Young's modulus, the stress divided by strain, okay, is the relationship simple in a one dimensional stress system. If you are going to consider the two dimensional stress system, okay, two dimensional stress system means here we are going to consider the two dimensions of the body. Earlier we have considered only one direction, effect of stress only in one direction. Here we have to consider the effect on body by considering the two directions. So for that, initially to study this, But to understand this, we have to know certain technical terms in this also, and that is longitudinal strain. Okay, we have to know, and then we have to know what is meant by lateral strain, longitudinal strain and lateral strain. In word, this initial word is also it clearly we are going to understood that longitudinal means what. Always in engineering drawing, we are going to say that take longitudinal section of the body or material. In that case, longitudinal means along the length. If you are going to measure any body along the length, that dimension is called as a longitudinal dimension. So here we have to calculate the longitudinal strain. What is the longitudinal strain? Okay, and second is a lateral strain. Lateral strain means when you are going to take or measure or cut the section perpendicular to the length or the direction, that is called as a lateral. So here that two things you have to keep in mind: what is meant by longitudinal strain and what is meant by lateral strain. So what is longitudinal strain now? So when body is subjected to an axial tensile load, there is an increase in length of body. Here you can see this when you are going to stretch the body. Okay, here suppose this red color is original body, and if you are going to stretch this body, what happens when body is subjected to axial tensile load? There is an increase in the length of the body. So here you can see the old body is red one and the extended body is blue one. Okay, so the body length is increased. So but at the same time there is a decrease in other dimension of the body at right angles to the line of action of the applied load. Here you can see this is original body. This side at p direction of load side along the length, the body dimension is going to increase. But same way, if you are going to consider the depth of original body, that depth is going to reduce. Okay, decrease. So here you can see this, the right angle line of action, the applied load, the decreases. Thus the body is having axial deformation and also deformation at right angles to the line of action of the applied load. That is a lateral deformation. Okay, already I have told you lateral means what. This is longitudinal along the length, and lateral means perpendicular to the length. So lateral deformation is there. So original shape of body is red color. Okay, and after stretching the body, after they applying the tensile forces to the body is elongated in a longitudinal direction and the decreases in the lateral direction. So that is called as a lateral decrease. Here lateral deformation. Okay, so here you can see the ratio of this axial deformation to the original length of the body is known as the longitudinal strain or the linear strain. Simple definition, you have first, or you people have understood already what is meant by longitudinal strain along the length. Lateral strain means perpendicular to the length, and the ratio of axial deformation to the original length of body is known as a longitudinal strain. So this is axial deformation along the length deformation, that is called as a, so that axial deformation to the original length of body is known as a longitudinal strain. And the longitudinal strain is also defined as the deformation of body per unit length in the direction of the applied load. Okay, so direction in the applied load, this body dimension is going to deform. Okay, and that's why we are going to consider the definition of this longitudinal strain. We can define like this: the deformation of the body per unit length in the direction of the applied body. Okay, so here you can see this. This is original length and extended length, change in length. This is delta n. So this is change in length. This length is increase, delta n. Okay, this is total length plus delta n. This is the increased length due to the tensile load applied. Okay, here you can see let L is the length of body, P is the tensile forces, and the delta n increase in the length of the body in the direction of P. Okay, and then we can write here longitudinal strain is equal to change in length or axial deformation along the length divided by original length of the body. Okay, so this is about the lateral longitudinal strain. Same way we are going to see now lateral strain. What is lateral strain? The strain at right angle to the direction of applied load is known as the lateral strain. Already I have explained you. This is longitudinal strain. Okay, and right angle to this length, the strain which you are going to consider, that is called as a lateral strain. The strain at right angle to the direction of applied load is known as a lateral strain. Let, now we take the example, let the rectangular bar of length L, breadth B and depth D, whatever this bar we have considered, if you are going to cut cross section, if you are going to see the cross section of that bar, you can, we can see here breadth and depth of that bar having the total length L, and depth D is subjected to axial tensile load P as shown in figure. So here you can see, okay, the length of bar will increase while the breadth and depth will decrease. Already I have told you, length is going to increase and breadth and depth is going to decrease. So here in plan you can see this. If B and D is the original cross section of the bar, when the length is going to decrease, if you can see this dotted line in plan or in cross section, you can see this. So there is a decrease in depth and width of the bar. So I can write here total depth D minus change in depth, that is decrease in depth, and here also B minus decrease in total depth, in total width. Okay, so here I can say that the length of bar will increase while the breadth and depth will be decrease. Here I can say here delta L is an increase in the length. We use here delta L is increase in length, delta B decrease in width. Okay, already I have told you, and delta D is a decrease in a depth, and the longitudinal strain definition delta L divided by delta L, L, and the lateral strain here delta B divided by L or delta D divided by L. So this is about the longitudinal strain and the lateral strain. Now next thing, after knowing the systems, one dimensional system, okay, two dimensional system, in two dimensional system of the strain, we have seen the what is longitudinal strain and what is lateral strain. Now next important thing we are going to see that Poisson's ratio. What is Poisson's ratio definition? The ratio of lateral strain to the longitudinal strain is a constant. Okay, the ratio of lateral strain to the longitudinal strain is constant, and that constant is called as a Poisson's ratio. Okay, so for the given material, when material is stretched within the elastic limit, this ratio is called as a Poisson's ratio, and it is generally denoted by mu. Okay, so lateral strain here mu into longitudinal strain. If by using this formula we can write here, so lateral strain is equal to mu into longitudinal strain. So as lateral strain is opposite in the sign to the longitudinal strain, already we have seen when longitudinal strain is increased in other direction, lateral strain is going to decrease. So the nature of sign will be opposite. So that's why I can write here lateral strain is equal to minus mu into longitudinal strain. So this is about the definition of Poisson's ratio, that lateral strain divided by longitudinal strain. Okay, so this is about the Poisson's ratio. Next lecture we are going to see the three-dimensional system, or in two-dimensional system, and how we are going to establish the relationship between the stress and strain. Okay, so today we are going to stop